Hey guys, in today's lesson I want to go ahead and talk about using half angle formulas. And the half angle formulas, we derive them actually from the double angle formulas. And actually these are the ones that we're going to be using today. So if you remember from the previous video, the cosine of the double angle is equal to 2 cosine squared u minus 1. And what you're going to do is you can rearrange this guy, okay? To figure out the half angle, we're going to replace the u with u over 2, which makes sense. So if we're going to replace that, we're going to take this guy, put him in here. The 2's are going to simplify out. You're going to be left with cosine of u. So now we have this, and what we're going to do is we're going to solve for this value here, cosine of u over 2. So we're going to add 1 on both sides. We're going to divide by 2. Then we're going to take the square root. And then when we take the square root, we're left with cosine of u over 2, which is the half angle. Now, it's always plus or minus, and depending on where the angle is located, you're going to use a positive or the negative. Same thing with this guy, the sine half angle. All right, we do the same thing. U over 2, these guys simplifies out. You add 1. Okay, and actually, let me go back a step. Here we have this. What I decided to do is the negative 2 sine squared of u over 2, I brought him to the left, and this guy, I brought him to the right. So that's what happened here, okay? So this simplified out. So this guy to the left, this guy to the right. So that's why you have this guy now becomes positive, and then the cosine of u is negative. Just a lot easier to do it algebraically. And then divide by 2 both sides, take the square root, and then you have 1 minus cosine of u over 2. And of course, again, anytime you take the square root, you have a plus and a minus. And depending on where the angle is located is what's going to determine if you have a positive or a negative. And your textbook might have something that looks like this. You see how it's 1 plus cosine of u for cosine, and then 1 minus cosine of u for the sine angle. I didn't do tangent just for sake of time, but this is what it would be. Okay, the half angle of tangent is 1 minus cosine u over sine u, or sine of u over 1 plus cosine of u. And unfortunately, just one of those things you're going to have to kind of memorize as well. So let's look at some examples, see if we can do some of these problems. It says find the exact value of cosine of 105 degrees. Now there could be more than one way to do this, but in this particular situation we're going to focus on using the half angle. And one thing I want you guys to note is that 105 degrees is half of 210. And 210 degrees, we're able to figure that out. I believe that's 5 pi over 6. And we're able to figure out that value on the unit circle, okay? And the reference angle is 30 degrees, okay? So what you want to go ahead and do is we're going to find cosine of 105. If you notice, cosine of 105, if I double them, okay, because this is the half right here, this is the half. If I double it, I get this guy over here. So then I have 1 plus cosine of 210. Cosine of 210, that gives you negative root 3 over 2. Okay, remember 210 degrees, that's a 30 degree angle. 30 degree angle is right here. The cosine is the top, 1, 2, 3. And then where's cosine of 210 located? That's located in the third quadrant. And in the third quadrant, cosine is negative. Okay. Now, maybe I should just kind of draw it out real quick here. And here's 30 degrees, right? If I do 180 degrees around, that gives me 30 degrees plus 180 is 210. And you can see here it's on the third quadrant, and this guy is negative, right? Because you would have to go to the left negative and then down negative. And so here cosine is negative. And that's why it's negative root 3 over 2. Okay. So now that I have that, I just have to do my algebra. And this looks kind of funky because you can have a square root within a square root. What I did here is you multiplied everything by 2. Okay, the inside here. Distribute the 2 times 1. And then these 2's cancel out. You're left with radical 3. On the bottom, remember, whatever you do on the top, you do on the bottom. This becomes a 4. The square root of 4 becomes a 2. That's why the radical is only on the top now. And that's it. I would leave it like this. Your professor is probably going to ask you to leave it like this. But that's just basically how you use the half angle formula. Okay. Notice that the angle, if you double it, becomes something that you can actually figure out with your unit circle. All right, let's do a few more. It says use the half angle formulas to determine the sine, cosine, and tangent of the angle. So we're going to use 75 degrees, but we're going to use sine, cosine, and tangent of all the half angles. So sine of 75, that's what I start with. Now remember, if I double this guy, I end up with whatever's inside here. So it's 150. Sine is the one with the minus. Cosine is the one with the plus. And I just do the math. 1 minus cosine of 150 divided by 2. Cosine of 150, okay, comes out to be negative root 3 over 2. All right. And then 150 degrees, that's in the second quadrant as well. And you can do the math as well. 150 degrees, I'm used to the radians, but that would be, what is that, pi over 6, that'll be 150 degrees, yeah. 5 pi 6 minus 1, 5 pi over 6. And it would give you negative root 3 over 2 here. Okay. So let's go ahead and just do that. If you're not used to it, 150 degrees, change it into radians. So let's see, pi over here, 180 over here. That's going to give you 15 pi over 18. Divide both sides by 5. 15 divided by 5 is 3. Oh no, I can't do by 5, I got it by 3, sorry. 15 divided by 3 is 5. 18 divided by 3 is 6. 5 pi over 6. Okay. And then you're able to figure it out. And then pi over 6 is over here. And then 6 take away 1 is 5 pi over 6. Okay. And then pi over 6 is your reference angle. So pi over 6 is right here. 30 degrees. And then what is cosine? Is on the top, root 3 over 2. So let me go back over here, because 210 is not 5 pi over 6. Let's figure out what that guy is. So 210 degrees, okay, we pi, and then 180 degrees. That's going to give me 21 pi over 18. We're going to divide by 3, and we're going to end up with 7 pi over 6. So this guy, 210, is 7 pi over 6. My correction. And then 150 is 5 pi over 6. Okay. So now that you have that, you have this guy here, negative root 3 over 2, and it makes sense because it's in the second quadrant. Remember, you go backwards, so that means cosine is negative. You have two negatives, becomes a positive right here. And then you do the same thing with the algebra. Multiply both sides by 2, top and bottom. And you get 2 plus radical 3. On the bottom you get 4. Square root of 4 is 2. And you just leave it. What about cosine of 75? Well, it's the same thing, except now it's just plus, right? But with this negative, it's going to end up being just a minus. You distribute the 2, right? Because you want to get rid of this fraction. 2 times 1 is 2. These 2's are going to cancel out. You're left with the radical 3. 2 minus radical 3. 2 times 2 is 4. Square root of 4 is 2. Notice the radical is down here, but now over here there is none because it's a whole number integer. And you just leave it that way. Let's do tangent. Tangent, you can do either one of the two that I showed you guys, but I just decided to do this one, sine of 150. The sine u plus over 1 plus cosine of u. So remember, you want to double this guy to get whatever this angle is right here. So sine of u is sine of 150 over 1 plus cosine of 150. And we already did 150 is 5 pi over 6, which is going to be 1/2. Okay. Pi over 6 is right here. Sine is 1. So it's 1/2. And then over here you have 1 minus root 3 over 2. 1 becomes 2 over 2. 2 minus radical 3 over 2. Now this one I kind of just did a quick trick right here. If you ever have complex fractions and the denominators are the same, you see how they're the same here, guys? They just actually simplify each other out. Okay, if you want to do it the long way and do the division, you'll find out that they simplify each other out. But the answer is 1 over 2 minus radical 3. And I think I'll just kind of take a quick minute there to do it to show you guys. So you have 1/2 on the top divided by 2 minus radical 3 over 2. And then what do? Well, you keep it, you change it, and then you do the reciprocal. And then 2 minus radical 3. And you can see the 2's simplify out. But whenever you see the bottoms are the same, I just cancel them out right away. Over here, your professor's not going to allow you to have a radical in the denominator, so you have to rationalize it. So how do you do that? You multiply by the conjugate. These guys are the same, so instead of a negative, you use a positive. And what you're going to do is distribute. And this is like multiplying a perfect square. On the top is simple, and then this becomes 4 minus radical 9, and the radical 9 is 3. Just in case kind of confuse you, let's see. Let's go ahead and do it the long way. 2 minus radical 3, and then 2 plus radical 3. So then 2 times 2 is 4. 2 times radical 3 is 2 radical 3. Do on the bottom is going to give you negative 2 radical 3, right? Negative this times this. Negative square root of 3 times 2. And then negative times positive is a negative. Square root of 3 times square root of 3 is square root of 9. Alright, so you have 4. Notice these guys cancel each other out. Square root of 9 is 3. And that's how we get it. And that's why the reason we want to multiply by the conjugate, because we want to get rid of these radicals. That becomes a 1, and that's your solution. Alright, guys. Let's do couple more. I want to do one with radians, okay? Pi over 8. Let's say they ask you to find the, I don't know, cosine of this half angle. Well, you just have to kind of recognize that it is a half angle, and if you double it, you end up with 2 pi over 8. Well, 2 pi over 8 is the same thing as pi over 4. Pi over 4 is cosine, right? Pi over 4 is in the middle. Fold that guy. Where's cosine? The top. 2 fingers, square root of 2 over 2. And then you do much the same thing. Multiply the top by 2. The bottom by 2, you get 2 plus, these guys cancel out, 2 plus radical 2, and then square root of 4 is 2. And you can see how the radical is inside the radical. But you just leave it like that, and that's a perfectly acceptable answer. The ones that are kind of trickier, the only one they give you a triangle. Sometimes, because you do have to use a triangle, but they give us 3, they give us 4. What you have to use is the Pythagorean Theorem in order to get this alongside the hypotenuse. So that's going to be 5, and you're going to have to use it. So remember, cosine, this is what they give us, cosine of pi theta over 2. Okay, they don't give us any else of this. So if you double this guy, you're going to end up with cosine theta. And, well, what's cosine of theta? Well, it's adjacent over the hypotenuse. So that becomes 4/5. And then from there, you just do your algebra. 1 whole becomes 5/5. 5 plus 4 becomes 9/5. On the denominator, you have radical 2, okay? I just decided to go ahead and multiply the top and the bottom by 5 because I don't want the fraction. So I ended up with radical 9 over radical 10. That gives me 3 over radical 10. Remember, you can't leave the radical in the denominator. You have to rationalize it. Multiply by the radical 10, and you end up with this guy right here. Okay? One quick note, because sometimes these you might get degrees that are decimals using minutes and seconds. Remember that when you get something like this, 65 degrees, 30 minutes, this guy's a minute. So there's just like 60 minutes in 1 hour, there's 60 minutes in 1 degree. And then that's used for navigational purposes. But what you want to do is 30, because this is the minute. 30 divided by 60 would give you the 0.5. So this would end up being 65.5. If you ever had seconds, you would use 3600, because there's 3600 seconds in 1 degree. Okay, and that would be the one with the two little lines here. But just keep that in mind. Sometimes I see this come up, and hopefully that'll help you guys out. All right, guys, till next time.